Hey you guys, welcome back. So we are getting pretty close to the end of this term actually. I think it's like the end of June now, and then there's like literally like 2 more weeks I think after this. So you're getting pretty close to the end of your summer math class. We're going to go ahead and work today on level D of the math course, and this is the fourth topic, which deals with it's all geometry in this topic, and so the main ideas are talking about circles. We're going to dive into some more detailed information about different types of angles, and we're going to talk about proportions of different shapes. So I was making the notes for this, and there's two things that I decided to do. So first is this is actually just a part one that we're going to be doing today, and that's all we're going to cover this week, because it's kind of in depth. There's some pretty important things about geometry that you need to sort of capture from this section. And then the video that we record for next week will be the rest of the stuff inside of this topic. I figured it would be best to slow it down a little and not totally overwhelm you guys with just too much information happening, especially because it's getting a little more and more complicated now. And the second thing that we need to make sure that we take note of is that we talked about angles before. There was like an overview or an introduction to angles, how angles are formed, how do you read angles, how do you write the symbols for those angles, and that was in level M, topics 4 and 6. That was the name of the video, and there was a section in that about angles. And so before you, like, if you are not at this point yet, like if you haven't done that video yet, or if you don't remember much about that video or that part of that video, I highly recommend that you go back and watch that first before you try and do this section here, because this might be a little like over your head if you haven't done the prerequisite stuff. Also, if you can hear my fan noise in the background, I'm sorry. I tried my best to sort of cut it out with my microphone, but my air conditioning is like on the fritz again, and so I'm just trying to like stay cooled while we're doing all this. All right, so let's go ahead and jump in. We're going to start by talking about angle pairs. That's the entire topic for today, and there's two different types of angles that we're going to be talking about, how they're formed rather. The first we're going to be talking about is angle pairs, and these are different types of angle pairs that are either on a straight line, or they make up 180 degrees, or they make up 90 degrees, and then we're going to talk about what happens when you have parallel lines that are cut by a transversal. So the first thing we need to talk about is adjacent angles. So if you think about the word adjacent, right? So I just circled that, adjacent. So the word adjacent means that it's next to something else. So like if you're in like a, someone's giving you directions, like you call a store and say, how do I get to your store? And they say, oh, we're in such and such plaza and we're adjacent to Publix. So that would mean that those two stores are next to each other, okay? And the same logic applies here. When you have adjacent angles, that means that the angles are next to each other. So if we look at our diagram, we have an angle here, and then we have another angle here, all right? And I'm using two different, honestly, I don't even know what you call these, but they're markings that describe the angle. And so since this angle is a certain measure, I don't know how much, and this angle could be the same or it could be a little larger. I don't really know. I'd have to get a protractor out and measure it to be sure. Since I don't think they're the same, I used 2 notches on this one and only 1 on this one to demonstrate that they're not the same size, or may not be the same size. If I put 1 mark on each of these, that would mean that they were congruent. They were the same measure, but that's not really given here, so I don't know that. So I'm marking them separately like this. But you can tell that they are next to each other because this entire thing, ABD, is kind of split actually by this line in the middle, which is this ray um, um, that has a point C in it. And so the two angles that are adjacent to each other are angle A, B, C, and angle C, B, and D. And I'm going to erase that and just use two different colors here. So we're going to use ABC, that's one angle, right? And then the other angle that you see here is CBD. So that's your two angles. Those two angles are adjacent to each other, okay? That's what the definition is for this term. And you might want to jot that down because that is what this diagram is portraying. ABC and CDE are two adjacent angles. They're next to each other. Now this says nothing about the measurement of those angles. We are told nothing about them having to add to a certain amount or be the same measure as each other. This is pretty basic. This is just that they are next to each other and that makes them adjacent. So I'm going to scroll my notes a little. We're going to talk also about something called a straight angle. So a straight angle is exactly 180 degrees. So you might never have actually thought of this as being an angle, okay? Because this is just a line, right? This is line AC or AB or BC. This is line AC. It continues infinitely in both directions. And you might not have ever thought about this as being an angle because there's not like you typically see like a ray that goes this way, or if it's not like that, it might be like a ray that comes out this way or something like that, right? Like that's how you would normally see this. But this is actually an angle, and the way you can think about that is sort of like, let's say it was like the hands of a clock, right? So like if you have a clock, right? Here's some angle, right? Like that might be 90 degrees or 89 degrees or something like that. I don't know. It doesn't really matter. The important part is that you can actually take, let's see if I can actually do this on my thing here. No, that selects the whole thing. Okay, so let me do it in a different color. Hold on one second. Let me just erase this. I'm going to draw my clock in red. Okay. And that's a crude drawing, sorry. And it's whatever o'clock that is. Okay, this is an angle here, right? Isn't that an angle? So if you actually took this side of the angle, and I'm trying to see if I can drag part of this, or I know what I have to do. Okay, hold on. I'm using this really cool tool named Cami to like draw on my document here, and sometimes it's a little, you just got to figure out like the right thing to do. I'm still drawing. Hold on. Shape. Line. Okay, that's your line, right? We're just gonna go with that, and that's some certain degree or whatever, and that's definitely, it's an angle, right? But if you turn that line this direction, like it keeps going all the way, like this is an angle, right? It's just a larger angle, but you can keep going, right? Until these are perfectly like across from each other, I guess you could say. And this entire thing here is an angle, and that is 180 degrees. I mean, roughly. This is not a super like right, I didn't use a ruler to draw this, but for demonstrative purposes, this is 180 degrees, right? That's what's being demonstrated in this picture right here. It's a straight angle that measures 180 degrees. So that's what you need to know about straight angles. They measure exactly 180, okay? And that's going to become important as we move on to the next thing, because we're going to be referring back to the definition of a straight angle. Okay, so let's slide this down a little, and we're going to go to the next page and talk about what linear pairs are. Okay, that's the next topic, is linear pairs. So let's say you have that straight angle, right? Like, let's change my color here. Let's make it white, because I want to cross something out, right? Oh, that's yellow. That's not going to help me. white. Okay, so it's still yellow. Anyway, I don't know why I can't make this the color I want it to be. There we go. Okay, so pretend this wasn't here, right? We're just gonna cross this out. We're just gonna do that temporarily, right? What would you call the size of this angle right here? Well, that's a straight angle, which is something we just talked about in the last section, right? So we know that this is going to be 180 degrees, okay? And then let's say that you add the ray to that, right? So I'm putting it back. I unerased it, right? So let's say you add the ray back. That's this ray here, DB or BD, okay? Now you have, because these are intersecting, right? You have an angle that's here, and you have another angle that's on this side, because now you have two angles. That this is almost like being split in half or cut by this other ray that was drawn in, okay? And so the whole thing is that the two angles are a pair. There's only two of them. There are two. That's important. There's only two. They are on a line. They are adjacent to each other. On a line, adjacent, and they add to 180 degrees. That's all the things that the angles need to be in order for you to be able to call them a linear pair. Okay, so so that's the gist here with these linear pairs, right? So if let's say I decided to draw in, I'm going to use a different color, like how about yellow? Let's say I decided to draw another angle right here, okay, and we'll call this point E, okay. Wow, that's really not very easy to read, but whatever. How about green instead? Okay, so here's your angle. There's your point. Okay, so let's say we decided to draw this ray in. Now there's how many angles? We have one angle, we have two angles, and we have a third angle, right? So we have three angles altogether. Well, that's no longer a pair because that doesn't meet the definition. It has to be two angles that add to 180 that are adjacent on a line. These three angles are all adjacent. They're on a line, and they would add up to 180 degrees. The total measurement here hasn't changed, but you no longer have a pair because you don't have two angles. You have three now. So just keep that in mind, okay? I'm gonna erase the green and the yellow and leave all the blue there, okay? And finally, we might just want to put like some highlighting. So that's an angle, and then this is also an angle. That's your other angle, okay? Okay, so all of that, all the things we just talked about were adjacent angles, which are next to each other, straight angles, which add to 180. I mean, which are exactly 180. It's one angle that's 180 degrees. And linear pairs are two angles that add to 180. The next thing we're going to be talking about is something called supplementary angles, okay? Now, if you go on to study any amount of geometry, supplementary is something you're going to hear pretty often, especially when you're talking about angle measures, because it's a terminology that we use in proofs all the time. So supplementary angles have to add to 180 degrees, okay? So if you go back to our last thing we talked about with the linear pairs, these are supplementary. They supplement each other. They add to 180, okay? So that's a linear pair is an example of something that is supplementary, okay? Now be careful, all right? This is very important. Be careful, because just because something is supplementary does not mean it is a linear pair, okay? So linear pairs are supplementary, but supplementary angles are not always linear pairs. Okay, that's important. Okay, that's very, very important. That's a huge distinction in logic and geometry. Linear pairs are supplementary, but supplementary angles are not always linear pairs. There's another way that you can have supplementary angles where they don't have to be on the same line, and that's an example that we have right here. You have one angle that's 120 and a different angle altogether. They're not on the same line or the same figure or the same diagram, okay? But 120 and 60 adds up to 180, and therefore these angles are supplementary, okay? They fall under that definition, all right? Supplementary is kind of like the bigger umbrella, and then linear pair, like here, is sort of like a sub-definition or one possible example of something that is supplementary, okay? It's sort of like saying, like let's say we have a category, right? Let's call the category meat. And then beneath that, you might have different types of meat, like bacon, for example, right? Or ground beef, or or steaks, or whatever it is. So steaks are meat, but not all meat are steaks. Does that make sense? And that's sort of what I'm trying to explain here with the supplementary angles. So this is supplementary, but not a linear pair. At least in the way it's drawn, it's not a linear pair, right? If these two were to be put on the same line, okay, like let's say you drew it like this, and this one was 60 and this one was 120, okay, this would be supplementary and it would be a linear pair because they're on the same line and they add to 180, okay? But the way that it's drawn here, this is supplementary but not a linear pair, all right? Okay. We have another concept here which takes it a little bit smaller scale. We have a concept called a right angle. So right angles measure exactly 90 degrees, not any more or less than that, okay? And in a 90-degree angle, in a right angle, you will see this little square icon that's drawn at the angle, okay? So normally when we're talking about angles, right? Like we would use like this little curvy, like semicircle or whatever you want to call that to sort of like denote like the angle we're talking about. In a right angle, this little symbol right here means that it's 90 degrees or it's a right angle. You can always count on that. If that symbol is written there, that means that it's a 90-degree angle, okay? What else do we need to know? Okay, so right angles are a really important concept in geometry, especially when we talk about triangles and the Pythagorean theorem, and that's going to be a topic that we delve into next week, okay? But just keep in mind, okay, that a right angle being 90 degrees is a super important piece of information related to the Pythagorean theorem, so don't forget that, all right? And then we have a concept called complementary angles, and this is exactly like supplemental, okay? It's exactly the same, except they add to 90 instead of adding to 180. So you can have something like this, where this is two different angles that add up to 90, and I know for sure that they are 90, not only because they told me 90 degrees, but because there is that little square icon here in the corner. So I know the whole thing adds to 90, and then, or it is 90 degrees, and then this angle plus this angle here is going to give me 90 degrees. I don't know exactly what this is. It might be like 30 and 60, or 40 and 50 or something like that, but they add together to make 90. I'm just going to erase that. And then you could also have complementary angles that are not on the same figure, okay? And so that would be this example here where you have one angle that measures 30 and another that measures 60. Well, 30 and 60 adds up to 90. And so that would be a complementary, these angles would be complementary to each other. Okay, so that is sort of like the basics of like supplementary and complementary angles. There's a little bit of practice on this inside of the Delta Math. So you have a choice if you want. I didn't put any practice problems in the notes for this, but there definitely are some on Delta Math, and they ask you like if this angle is this much and they're complementary, what's the other angle, and questions like that to practice with the definitions. If you want, you can actually pause the video here and go to Delta Math and do those now before we start doing the next section, because the next section is a little trickier. Okay, I would definitely recommend doing that and just really making sure that you have this definition down for things like complementary and supplementary. Okay, in the Delta Math there are 2 topics there that you're going to be quizzed on. The first topic deals with everything we've talked about so far. The second topic deals with what we're about to talk about. So don't do the second topic, only do the problems from the first topic. Okay, so let's move on to the concept of angles that are formed by intersecting lines. Okay, so there are definitely situations where lines will intersect. If you want to put this into something concrete from the world around us, think about like an intersection of 2 roads. So that is like that's similar to having 2 lines that intersect with each other. And when you have that intersection, that point of intersection right in the middle here where the 2 lines cross is going to form 4 angles. Okay, there's going to be an angle here, an angle here, an angle here, and an angle here. And we use this information to sort of like figure out these angle puzzles in geometry, and everything you're about to learn is the rules that you can use to figure out what other angles are based on whatever information you are given. So the first thing you need to know is that vertical angles are congruent, okay? So vertical angles are congruent, and congruent means that they have the same measurement. So what is a vertical angle? So if you have an intersection, right, like this, the vertical angles are the ones that are across from each other and they form a pair, okay? The other 2 vertical angles are this one and this one, and those are also going to be congruent with each other. That is just a fact. It's a piece of information inside of geometry that we rely on that definition. It's a theorem that we rely on to prove geometrical, mathematically reasoned arguments about geometric figures. This is an important piece of information. These 2 angles are congruent, and these 2 angles are also congruent. They are vertical from each other, okay? So just to clear that up, this angle right here, okay, and this angle are congruent. I'm actually going to fix that because I picked up my pencil by accident. Okay, those are congruent. And then you have the other set of vertical angles here, which is here and here, and those are also congruent with each other. The blues are going to be the same measure and the reds are going to be the same measure. Okay, so just keep that in mind. That is the definition of vertical angles. That's going to be important to know from going forward, and we'll do some examples to show why. So scrolling this down, we can also have a situation. This is actually the last part of this topic. We can also have a situation where you have 2 parallel lines and they are cut by something called a transversal. That sounds like a whole lot of mathematical jargon, so we're going to break it down piece by piece. So what are parallel lines? Okay, let's break that down first. So remember, parallel lines, right, are lines that run next to each other. I'm making it a line because it goes on forever in both directions, right? And we'll call this like line A, B, and we'll call this one line C, D. And these two lines are never going to touch. And I'm going to note that they are parallel because they have this symbol drawn on them, okay? This little marking, this symbol, means parallel. That's how you know when you look at a diagram of something if the two lines are parallel to each other. So lines AB and CD are parallel. They run alongside each other, but they never touch and they never cross, okay? The other situation that you're experiencing here is not only do you have these two parallel lines, but you also have the idea of something called a transversal. And all that a transversal is when you have a third line and it cuts through the two parallel lines. So if we look at our first diagram here, here is the depiction, the drawing of what a transversal is and what it does. So first things first, they actually forgot in this diagram to put that these are parallel. So I'm just going to add those symbols. Now you know that those two are the parallel lines. And then you have the red line which cuts through them, which is called the transversal. And if you remember when we were talking about vertical angles, right? When you have a situation, I'm actually going to use my hand and just kind of cover the bottom of this for right now. Just look at this right here, right? Whenever you have two lines that intersect this way, there are four angles that are formed. Well, what's happening here is you have that same line cutting through another line, and you have another four angles being created, right? And because these are parallel, and this is the same one line that's cutting through both of them, there are things that we can say about the relationships between these angles right here, okay, in terms of which ones are going to be the same measurements, which ones are going to be supplementary, and so on and so on, okay? And that is the whole gist behind what a set of parallel lines are that are being cut by a transversal, okay? It's a big mathematical word, but that's really all that it's saying. We're trying to break it down so it's easier to remember, okay? Okay, the first type of situation you're going to run into here when you have parallel lines cut by a transversal, once again, they forgot the parallel symbol, so we're going to add it, okay? The thing you have to look at is sets of corresponding angles. So if you look at the placement, right, this has four angles, right? The first set of angles up here, this has A, B, C, and D. Well, on the other set of angles, E, F, G, and H are in the same exact position as A, B, C, and D are in terms of what angles are created by this transversal cutting through them. So that means that C and G are going to be congruent with each other. And every other set of corresponding angles is also going to be congruent. The key word here is corresponding. So how can I put this in a different terminology? If you think about, let's say you have, do I have some blank space at the bottom here? Let's see. Yeah, I kind of do. I'm going down. I'm just gonna. You don't have to draw this, but I'm gonna draw I'm just gonna draw a diagram. So like, let's say you're making dinner, right? And you're making dinner for two people, all right? And so this is person one's plate, and this is person two's plate. That says plate, in case you're wondering. I'm drawing really quickly. But you want the plates to be identical so that, you and the other person are getting the same exact amount of, the chicken or the beef or whatever you cooked, the same exact amount of the side, like the potatoes, and then the same exact amount of like the vegetables, right? So you might have the plate be split up kind of like this, right, in threes. You're going to have to go with me on this, pretend they're exactly the same. Well, the angle of this section on this person's plate is going to be exactly the same as the angle on this person's plate. They correspond with each other. Let's say that this was angles A, B, and C. This would be D, E, and F. And I'll use a different color to say that angle B and angle E are going to be also exactly the same, because remember, you're putting the same amount of food on both plates, right? These are corresponding to each other, okay? It's almost like a repeating figure over and over again, and everything is placed in the same position. It's just that it's called a different letter so that you can tell the difference. The last thing would be angle C and angle F are also going to be corresponding to each other. I think my drawing for this one was much better than my other drawing. But anyway, so the thing that you need to walk away with this being able to say is that corresponding angles implies congruency, or the exact same measure. So I'm going to roll back up to our diagram, right? Here's where we were in the notes, all right? Corresponding angles are congruent. Because they are parallel lines, because the same line cuts both parallel lines this way, okay? You need these things to be true in order to say this. That means A and E are corresponding, B and F are corresponding, C and G are corresponding, and D and H are corresponding. They're in the same positions in both sets of angles, okay? Because all of that is true, okay, that means angle C is congruent with angle G. And you can say this about A and E, B and F, and D and H. I'm just going by which ones are already in red on the diagram here, but all of this is true for all four pairs, okay? These pairs, this corresponding pair of C and G, are congruent. This symbol where there's an equals sign and like a squiggly on top means congruent. Okay. All right. So there's two more things about this that we need to know, and that is alternate interior angles and same side interior angles, okay? So the way alternate interior angles works is that you have to think about this diagram sort of like this is the outside right here. Ooh, I zoomed way out. Sorry, hold on. Let me zoom way in. This is like the outside. And I'll switch colors to show that like these four right here are on the inside, okay? That's just the way you have to look at these diagrams. These angles are like between the parallel lines, and that's another way to look at it too. That makes them interior. Okay, so interior means that they are inside between the parallel lines like this. And the word alternate just means that they're on opposite sides. So when you have a situation, there's things you have to remember here, right? Okay, so they're parallel lines, all right? That has to be true. They have to be cut by the same line, which is this transversal right here. And they also have to be interior and on alternate sides of the transversal. Okay, if all of that is true, then the angles are congruent. So the thing you need to be able to draw from this, the conclusion, is that angle C is congruent to angle F. And you can say the same about the other pair of alternate interior, which is angle D is congruent to angle E, because they are inside and they are on the opposite sides of the transversal, okay? And then the last piece you need to know is about same side interior. So we are again talking about the difference between it being on the outside or the inside. So, oops, I don't know why I did that. Let me switch my drawing. Okay, this is, I should probably use the same colors, right? This is outside. and this is outside. So the interior angles are inside, and they are these four. Inside or interior. And then we're talking now about the ones that are on the same side of the transversal. So D and F are on the same side of the transversal. What they are is they are supplementary. So if you go back to the earlier part of these notes when we talked about supplementary, supplementary means that they add up to 180. So the thing you need to be able to walk away from this saying is angle D plus, actually, I lied. I should be using an M because we're now talking about the measure of the angles. The measure of angle D plus the measure of angle F, when you add them together, gives you 180 degrees. And I drew my degrees sign early, so let me fix that. Okay, perfect. You can also say that C and E make up 180 as well. So the measure of angle C plus the measure of angle E is also 180 degrees. Okay. That's all of them. That's all the things you need to know about the parallel lines being cut by a transversal and the different conclusions that you can come to in terms of how you can find different measurements, what's congruent, what's supplementary, what's 90 degrees, what's corresponding mean, what alternate interior means, etc., etc., etc. Something has to be one of these situations, corresponding, alternate, and same side interior, right? It has to be one of these things for you to get to the next conclusion, which is they're congruent or supplementary. Okay, so be careful when you're finding these out and make sure that you're able to sort of prove the situation to yourself using the definitions before you just assume, one thing is the other. You wouldn't go around saying, hey, the sky is green, without some sort of logic or reasoning that backs that up. You wouldn't make a decision to eat a certain thing for dinner that night or decide to go to a certain place if there wasn't some sort of reasoning or logical argument for you to take that action. And the same is true in geometry. There is always a reason for everything, and if you can't find a reason, it's probably not going to be a true conclusion. So I couldn't just draw some random figure and say, oh, these angles add up to 180, unless I have all of this information, in the background that sort of leads me to that conclusion. So let's go ahead and do an example. So here we have an example of two lines that are being cut by a transversal, okay? They are parallel lines. I'm just trying to cut out what I wrote up there. They're parallel lines, and there are 8 angles here, right? There's 1, 2, 3, 4, and then 5, 6, 7, 8, and I was only given one of the angles. Okay, so I need to use the one angle I was given out of all 8 to find the other 8 angles, okay? So the first thing that I can do, and I'm going to preface this by telling you there's many approaches, okay? You don't have to use the same approach that I'm using or apply the same rules. You might be able to figure this out with a different set of rules or just one or two of the rules that I mentioned, okay? The first thing is these two angles are going to be the same, and the reason for that is because they are vertical, okay? So the orange angle, I'm going to use the colors to sort of go with what I'm saying here. The orange angle, okay, it's 47 degrees because it is vertical from a 47 degree angle, okay? These angles are vertical to each other, so they have to be congruent, all right? I know that to be true because the definition of vertical angles is when you have two lines that intersect. The four angles that are created form two pairs of vertical angles. These two are the same, and these two are the same. And what do I do next? Well, let's use blue, and I'm going to say that this, oops, my color didn't change. 1 second. We'll use blue. This angle is also going to be 47. Okay. And I know this to be true. It's 47 degrees because it is complementary I don't know why it's not letting me draw the rest of this word. Hold on. There we go. It is complementary to the orange 47 degree angle down here. Okay, these are complementary to each other, and so I know that they are going to be the same measurement. What else can we figure out here, right? Did we prove any other of the rules that we went over already? Yes, we did. We have a set right here of alternate interior angles, and look at that. They are the same measurement. This is 47. It's 47 actually for two different reasons, and you might have taken the other approach. That's what I'm trying to say, right? These are alternate interior, so they must be the same, and you could have gotten this one without getting this one. Okay, you could have gotten the blue without getting the orange, all right? So that's how these rules are kind of like interchangeable. Like you can kind of use different ones to find different angles. Well, something else I know to be true here, and we'll do this in red, is that this angle right here is going to be also 47 degrees. There's two reasons. One, these are vertical, okay? So they have to be congruent. And then these two are corresponding, so they'd have to be the same measurement. They have to be 47 or they have to be congruent. So we'll do two reasons here. 47 degrees because it's complementary to the given angle and it is vertical from the blue angle. Okay, let me zoom that out a little so you can see all the stuff I'm drawing. What else can we sort of draw a conclusion about here? Take a moment, pause the video, and just think, what else can we figure out here? Do we have anything else being depicted here that we covered in this section? So the answer is definitely yes. We have a lot of things we could go off of next. But I can find the rest of these angles just by finding one of them. So there's something that we learned here, which was supplementary or linear pairs. These are a linear pair. These are a linear pair. These are a linear pair. And these are a linear pair. Okay? And since I know what one of each of the pairs is, right? Each of these is 47, so the other one must be whatever it takes to get to 180. I'm just going to do 180 minus 47, and I'm going to use my calculator for that because it's Sunday and I'm being super lazy. 133 degrees. This has to be 133 degrees because it is a linear pair with the orange 47 degree angle. Okay, and so the rest of this is pretty easy. You know that these two are going to be congruent. This is 133 because they're a vertical angle, right? You know this one's going to be 133 for a couple reasons. It's a linear pair with 47. It's also an alternate interior angle with this one, so they have to be congruent to each other. It's a linear pair with this 47 degrees, the red angle. And then we know this one's going to be 133 because it's vertical from this one. It's a linear pair with this 47, and it's a linear pair with this 47 this direction, okay? So there's many ways to find all of the angle measures here. And you can use different logical reasoned arguments to find them all. You could have just started out from the very beginning before we drew anything at all. You could have just started out by saying 47 and this angle are a linear pair, and I can find this because they have to be 180, right? And then once you knew this one, you could find this one. Once you knew this one, you could get this one. You know, there's lots of different approaches you could take. And so the key here is being able to remember the definitions of things like corresponding, alternate interior, same side interior. What does that mean? We can apply same side interior for sure because they're supplementary, and 133 and 47 has to be supplementary. That adds up to 180, and that's correct. Same for this side, same side interior. So yeah, there's some practice activities that I put together for this entire section of notes. There's a couple things you can do to practice this skill before you go into Essential Ed and do the practice there. And this is what they are. So first is the practice worksheet. I found a worksheet online. You can print it out, and it has you sort of like, the first thing is you define, let's see if that's actually, yeah, it's on here. So here's the worksheet, right? In the first page, you're just defining the ones that have a letter next to them, right? They're giving you a pair of angles. These are all parallel lines cut by a transversal, and they are asking you to define, what are these? Are they corresponding? Are they alternate interior? Are they so this terminology, consecutive interior, is same side interior. And alternate exterior, we didn't really talk about that, but it's a pretty easy definition. If this was your diagram, these would be the exterior or the outside. Okay, think about like your house, right? You have an interior and an exterior. If the angles were both on the outside, and they were alternating, like one. Okay, I'll give you an example of that. So this would be alternate exterior for sure, because this is the outside, this is the outside, and the angles are on the opposite side of the transversal. That's alternating exterior. Okay, in each of these problems, you're going to define what that is. There's only 8 of them. And then on the second page, oh, I'm sorry, there's actually 10 of them. On the second page, you go 11 through 18. That's 8 problems. And you actually are given some angle measures. And they don't want you to do the whole thing. You can if you'd like to. It's good practice. But they just want to know what's the angle that has the question mark. Okay, so check those out. Try out that worksheet, okay? If you printed the notes out, it's already there for you, so there's no reason not to, honestly. The other 2 things you can do is, one, I made an assignment in Delta Math. It has, I stopped the video earlier and explained it to you. You can do the angle pairs assignment on Delta Math. The first part deals with the first half of these notes. The second part deals with the transversal problems. And then finally, there's going to be some reinforcement, some additional explanation and practice problems that you can get from Khan Academy, and I'm gonna assign those to you guys now. That way you can start whenever you're comfortable doing it. But if you need that resource, it's there for you. So please log in and use it. Okay, guys. So you have tonight. This is Monday night's video. You have Monday night's video, Monday night's class time, which is 3 hours, and then Tuesday night's class time as well, to focus on getting these practice assignments completed. And also, you have to do those 3 hours of study time in Essential Ed. Okay, that's super important. Please make sure you're logging your study time in there. They have really great explanation videos as well that will reinforce what we're talking about in these videos, and you can get, certain topics just done and bang them out. And we're not going to finish everything that they have in the math course, but we're going to do a lot of it, and you'll be so super prepared for the next session, the next term, that you won't even believe it. So thank you guys. Enjoy your evening. I hope you enjoyed this video. Make sure you try these practice problems, and please reach out to me if you have any questions. I will see you guys later. Bye-bye.